Now we're going on to the second lesson, which is dealing with the laws of exponents and logarithms. Okay, and so yeah, that's what we're talking about today. So you probably have done a good bit with exponents before, same with logarithms, but we're going to talk a little bit about connecting those ideas. So let's start off by talking about what an exponent actually is. Right, that 4 at the top is an exponent. It's just a way to write an expression that has been multiplied by itself several times, right? And so in other words, this means x times itself 4 times, right? And it doesn't have to be an x, right? It could be a 2, right? Which just means 2 times itself 4 times. So it's a shorthand way to write something out, right? It's no fun to write it out that many times. And so that's what an exponent is, right? It's just a shorthand of writing out an expanded expression that's been multiplied together. That's not to be confused with when you add things together, right? If you add, let's say you added 4 x's together, well, you're not multiplying them, right? So this is just actually 4 times x, right? So you have something with an exponent, which means x multiplied by itself 4 times, and then 4 times x, which just means x added to itself 4 times. Okay, so that's what an exponent is. We kind of know that, I think. What is a logarithm, though? A logarithm is, I like to say, an answer to the question, to what power is 32? Okay, so that's just an example. Okay, and so the answer to that question, in other words, 2 to what power equals 32? Well, maybe you know that 2 times itself 5 times would be what you're looking for there, right? It would be a 5. But another way to think about that is that would be log base 2 of 32. Okay, so this thing, if you were to type that into a calculator, it equals 5. Okay, so you actually can see the connection here. You can see the connection there. 2 to the 5th power equals 32. Log base 2 of 32 equals 5. All the numbers are the same. Another way to think about that, it's an exponent. So 2 to the whatever this happens to be. This exponent is 5. Okay, the exponent is 5. So a logarithm is essentially an exponent that answers the question, some number, 2 to what power equals another number. And so we can use logarithms to solve equations, solve exponential equations. All right, so let's practice, first of all, connecting the ideas. So in that last example, we had 2 to the 5th power equals 32, and we said that we could rewrite that as a logarithm, or at least the exponent. So I want to write this in logarithmic form. I want to write a logarithmic equation. So let's pair up the ideas. So let me actually go back a little bit right here. These two is what I want to look at. And let's see if we can figure out where everything matches up. Okay, 2 and 2. In both cases, that 2 is called the base of the term. Okay, so on the left side, the 2 is the base of the exponential. On the right side, 2 is the base of the logarithm. Okay, but the base is going to be the same no matter what kind of equation you're writing. So if you're doing an exponential equation, 2 is the base. A logarithmic equation, 2 is still the base. Okay, the next thing that's easier to identify, let me write this out, this is base. The next thing would be the exponent. The exponent. Okay, and the exponent is always what the logarithm is equal to. Remember, we just said that logarithms are exponents. That's what they are. And so if I look at it like that, then the logarithm must equal an exponent, which is 5. So 5 is the exponent in both cases. So we can identify the base and the exponent. The last one, I just always call it the other one. Right? It's just that other one that we haven't done anything with yet. The 32 here. So 32 in this case is the value of the exponential expression. Okay. It will match up here. It's the interior of the logarithm. Okay. All right. So let's see if we can apply that. Base, exponent, and then other. That's how I like to think about it. So write this exponential equation as a logarithmic equation. Okay, well, the base is the easiest thing to identify, at least I think it is. It's the number being raised to a power. So I'm going to say my base is 4. So I put a little subscript 4. The next easiest thing to identify is the exponent. All right, the number that's the little number that's sitting on top, right? And that is going to be 3. Okay, so base, exponent, and then the other one, right? That other number, 64. So log base 4 of 64 equals 3. That would be my logarithmic equation, meaning the same thing. Okay, so now let's talk about determining the value of a logarithm. And so it does help to understand what it is you're looking at. And so one method to work this out is to, well, let's rewrite it. So log base 2 of 16 equals something, right? Some unknown value. So I just took this expression that I'm trying to figure out and I wrote it as an equation. Right? It's always a good idea to write something as an equation if you can, because you might be able to solve that equation, right? And then solve the problem. All right, so I'm going to write this now as an exponential expression because maybe that's easier to work with. So my base is 2, the little 2. My exponent is what the logarithm is equal to. In this case, it's my unknown. And it equals that other value, 16. Okay, so 2 to the x power equals 16. So this might be easier if you know your 2 multiplied out, right? And maybe you know that 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, fourth power is 16, and so on. Probably a good idea to learn the first 5, by the way. It's just helpful. Because if you know that, then you know that this right here has to be a 4. That's the only way that works. So in that case, x is equal to 4. Okay. So that's the ideal way to work it out. You don't have to use a calculator or anything. You could just think about it a little bit. Another way to think about this, though, and actually, let's go on to the next example that we can talk about. Just a different way to work this one out here is to think about that 36. And again, it helps to know 6 to the first power is 6. 6 to the second power is 36. So I'm actually going to rewrite this. I'll put 36 in red here. Okay, so 6 squared represents the 36. Okay, they're the same thing. Now, this is where exponential terms and logarithmic terms, you can really see the relationship between the two of them. Okay, exponential and logarithmic expressions are what they call inverse operations. You know plenty of inverse operations at this point, right? You know addition and subtraction. You know multiplication and division. You know raising something to the second power and finding the square root of something. All right, those are inverse operations. Okay, well, exponential and logarithmic, those are inverse operations as well. And so here we have, we'll stick with blue here. Here we have log base 6, and 6 is the exponential term, the base of the exponential term. Well, just like if you add and subtract 6 or multiply and then divide 6, they cancel each other out. And they leave you with whatever that exponent happened to be in the first place, which is a 2. Let's go back up to this one real quick. If you know that 16 is 2 to the 4th power, you can just write it as log base 2 of 2 to the 4th power. knowing that these two things would cancel out and leave you with the answer that you got earlier, which would be 4. Okay, so this is actually the way you should be thinking about it, if at all possible, because that's going to kind of make more sense as you get to more complicated equations. Okay, so we're not going to really talk about this much. I just want to show you, this is the laws of exponents and logarithms. And you can actually see, you probably know this, you've done this before in high school, I'm sure. But you can really see the connection between the two. If you're doing multiplication, right, product rule here, it seems to some kind of way take multiplication and change it into addition. Notice the same thing is true with logarithms. It takes multiplication and changes it into addition. Okay. Oh, there's a typo here. This should be a minus sign. Because it takes division and turns it into subtraction. Division and subtraction. It takes raising something to a power and changes it into multiplication. Okay, same thing here. Takes something raised to a power, changes it into, you can see it, multiplication. Okay, so anyway, that's the point I want to make there. All right, let's actually apply some of these rules. I know we didn't talk about them much, but I think it's easier to learn how to do this or to remember how to do this if you are doing it through practice, right? And seeing it worked out instead of me just saying a bunch of rules. All right, so let's work this out. I see several things going on here, and I'm going to break this up into 3 pieces. So there's this left piece right here. I'll focus on that first. And I see I have an expression for x to the 6th, y to the 7th, raised to the 2nd power. Okay, and so if it's raised to the 2nd power, then that means what I want to do is, it's in a way distribute. I'm going to say, well, this exponent applies to all 3 terms. So this is 4 squared, x to the 6th squared. And laws of exponents just say you multiply those together. And y to the 7th squared. Okay, and so let me just move all that the way. In the grand scheme of things, all that means is you have 4 squared, which is 16, x to the 6th squared, which would be x to the 12th. Remember, you just multiply the exponents together if you have something raised to a higher power. Just multiply them. So 6 times 2 is 12. Same thing here. That's going to be y to the 14th. Okay, so that's going to be that right there. On the right side here, I still have times 3y squared. I can't do anything with that. There was not like an exponent up here or anything. So I'll leave that alone. And then at the bottom, I'll leave that alone as well. 2x to the 8th, y to the 9th. Okay, and so now let's simplify that even further. And I like to, whenever I finish simplifying one line and I go to the next line, which is just a simplified version of the line before, I like to scroll up so I can't see that previous one. Sometimes it gets more confusing if you can see it all at once. So I'm ignoring the top part. This is what I'm working with now. The top, I see multiplication, 16x to the 12th, y to the 14th, times 3y squared. So pair up what's alike, right? 16 times 3. I know how to do that, right? 16 times 3 is 48. Okay, so that takes care of this. X to the 12th, I don't see any other x's, so I'm just going to go ahead and say, all right, x to the 12th. So that's taken care of, that's taken care of, oops, that's taken care of. I have y's now, y to the 14th times y squared. So remember what an exponent is, right? Y to the 14th just means y times blah, 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 y 14 times, right? Times y squared, which is 2 more y's. So we have 14 y's and another 2 y's, 16, right? So all I'm doing is adding those exponents together. That's why that rule works. Okay, and then all of that is over 2x to the 8th, y to the 9th. Okay, so now that's my simplified version so far. So ignoring what came before it. Now I see three fractions. They're all in one, right? I see 48 over 2. I can simplify that. That's 24. 24 over 1. Or just 24. X to the 12th, x to the 12th over x to the 8th. Okay, what do I do with that? I have 12 x's on top. Go ahead and write them all out. 11, 12. So that's 12 x's on the top, and I have 8 on the bottom. Okay, and when you divide, right, when you divide the same thing, this divided by that is 1. So that's 1 times everything. So basically it's not even there, right? 1 times everything is going to be everything. That's 1. That's 1. They essentially cancel each other out. And they leave me with 4 x's, right? X to the 4th. Of course, I wouldn't want you to write that out every time, right? The idea is this is why it works, but what's the rule? You just subtract those numbers, right? 12 minus 8. So you're left with 12 on the top. Now, if the 12 were on the bottom, you would subtract it and you'd put x to the 4th on the bottom, right? Because that's where they'd be left over. Okay, let's use that rule to simplify y. 16 minus 9 is just 7. So there we go. We have 24 x to the 4th, y to the 7th. All right, so let's do 2 more examples. I have an idea of which ones I want to do. All right, so I want to do this one. 2 to the 5th power times 8 to the 4th power. And the goal of this one is just to rewrite the expression, not to multiply it out, but to rewrite it. Okay, and again, I told you earlier, I really just want to reiterate, you want to memorize at least the first 5 of these. If you can memorize more, then great, but at least the first 5, because you'll recognize 8 is 2 to the 3rd power, and that's really helpful here, because I can rewrite this expression. I can rewrite 8 as 2 to the 3rd power. Okay, and then if I'm trying to simplify this, again, if you're raising something that has an exponent to another exponent, you multiply the exponents together. So we have 2 to the 5th times 2 to the 12th. And then add the exponents together, and I get 2 to the 17th power. So 2 to the 17th is this rewritten with a single base. I do want to quickly do this one. This is not one of the ones I want to work out, but something I want to say. Log base anything, okay? Pretty much any positive number here. If you have a 1 right here, it's going to equal 0. Log base 1, 2, well, not 1. Log base 2, 3, 4, 5. If it's of 1, it's going to equal 0. So the point of this example here, log base 8 of 1 is 0. All right, and then let's do this one, and then we'll be done with this lesson. Okay, so write the expression as a single logarithm. Okay, and so this goes to those logarithm rules that we kind of glossed over, didn't talk too much about. But let's talk about them real quick. First thing to do with this type of a problem is to notice that you have multiplication times the logarithm. Multiplication times the logarithm, and you kind of have that here, but we're going to ignore that because the minus sign, it's going to do something different. Okay, and so if you have a number multiplied times a logarithm, that number out in the front becomes the exponent on the whatever's inside the logarithm. Okay, so this is going to become log base 4 of n to the 3rd power. Okay, that 3 gets transferred up. You can, if you had this, wanted to write it the other way, you could always bring the 3 down. Okay, so it goes both directions. That's my point there. Okay, the next one here, plus log base 4. Here's that exponent, or what will be an exponent, goes on top of the m. Minus log base 4 of t. All right, and then remember what we said earlier. when you add logarithms, especially with the same base, that's really when it matters. But when you add logarithms, you can rewrite it as a single logarithm. I'll put it in parentheses so we know these go together. As multiplication. And when you subtract, it becomes division, just like with exponents. Oh, I gotta write this better. Okay, so again, things that are added, they become multiplication inside of the logarithm. Things that are subtracted becomes the denominator, right? It's divided inside the logarithm. Okay, so that's simplified. One last thing I will mention about this section. Notice this 1/4 power. Anytime you see a fourth power or a third power, a half power, that is simply the fourth root or whatever that number happens to be. It's a root. Okay, so you may want to look at it like that instead. All right.